Okay, boys and girls, welcome to Lesson 6, Unit 1, Lesson 6. And today, we're on page 20 in your notes. And our objective today, I know there's not a place to write your objective, but our objective today is to write a piecewise function based on a real-life application. So we're given some information here. So we're looking at the admission rates at an amusement park. So we have two things we're looking at. One is our age. So age would be our input value, our independent value. And our output value would be the cost. Our dependent value would be the cost, because the cost, that the amount you pay, is based upon your age. So in this scenario, they tell us that children under the age of 5 are free. Children between 5 and 12, inclusive, are $10. Children between 12 and 18 years are $25. And then the adults are $35. So let's write a piecewise function to do that. So since x is our domain, our x value, our piecewise function will be broken up by age. So we're going to have f of x is equal to, and then when a child is 0, and the reason I started 0 is because you can't be a negative age. So when a child is between 0 and 5, they won't pay any money, so they pay $0. When a child is between 5 and 12, so once they turn 5, so we're going to do 5 less than or equal to 5, and when they turn 12, well actually when they turn 13, they have to pay $10. So just simply $10. When they're between 12 and 18, then they have to pay $25. And then once they turn an adult, when they're over 18, so when they're greater than 18, they have to pay $35. That's how we break that up. Okay? So now we're going to graph this. So let's remember that the y value, we always have to label our graphs. So our y value is the cost. So that's what we're measuring on that x-axis. And on the x-axis, we're measuring the age. So between 0 and 5, and it should be a closed circle on 0 because you can't be a negative age. So between 0 and 5, they pay $0. But once they turn 5, so now that's a closed circle. Now they have to pay $10. So that'll be a closed circle on 10, and that's going to go all the way until they're 12. We just have to kind of estimate 12. And then when they're 12 or older, so we're going to start at 13. So I'm going to just put an open circle here on 25, on 12, so that's still on 12. So between 12 and 18, and we do a closed circle on 18. And then when they are 18, after age 18, until forever, they're going to pay $35. So we're going to put an open circle on 18. This is when they're over 18, they're going to pay $35. Okay? So what does this look like? What is the domain for this function? Well, the domains from this function, you can be as young as 18 and as old as infinity. I guess you'd have to look at what is your lifespan. And I think is that the only question that they ask? Okay. So that's it. This is called again, a step function, because just dependent upon your age is how the graph, how you would graph that. All right, let's do the second one. Now this next one is a little bit more difficult, and we're looking at how the salary of an employee. So let's say you have a job and you make $10 an hour. But if you work more than 40 hours, then you get paid time and a half. So time and a half, if you make $10, time and a half would be $15 an hour. Okay? But the most you can work is 60 hours. So between 0 and 40 hours, you make $10 an hour. Between 40 and 60 hours, you make $15 an hour. So this one is a little bit more difficult to do, but we still need to define our x. So let's x is equal to the number of hours, and y is going to equal to your pay, how much you're paid. So we know that we make $10 an hour, so our salary for every hour we work, we get $10. So that would be, this is going to be our slope. So our slope would be 10x. Our y-intercept would be 0, because if you work 0 hours, you make 0 money. So when is the time constraint for this? This is if you work from 0 to 40 hours. You make $10 an hour. But if you work over 40 hours, so if you work, but you can't work any more than 60, so if you work between 40 and 60 hours, and that should be not inclusive on 40. So if you work between 40 and 60 hours, then you make $15 an hour. Now here's where it comes in, where it becomes a little sticky here. The number of hours that you're working, the number of hours you get 15 for, is not for the entire 40 hours. You get $15 for every hour after $40, 40 hours. So if you work 41 hours, you get $15 just for that 1 hour. So that'll be 41 minus 40, 1 hour. If you work 50 hours, that would be 10 times 15, because you'd do 50 minus 40, which is 10. So we have to subtract out that 40. And what you would make would be this plus the 40 hours that you've already worked. So if you work 40 hours already at $10 an hour, that's $400. So if you were to work 45 hours, it'll be 45 minus 40, which is 5 times 15, plus the 40 hours that you worked previously. Okay? And so that's what our piecewise function would look like. So that is the piecewise function. So f of x is equal to $10 an hour if you work between 0 and 40 hours. You can only work 60 hours, so if you work between 40 and 60 hours, you're going to get paid $15 for every hour after 40, plus the $400 you made working the initial 40 hours. Okay? So let us graph this. So once again, let's label our graph. And the y-axis here is going to represent our pay. And the x-axis represents the number of hours. So if we work 0 hours, we make $0. And if we work 40 hours, we're going to make $400. So that first line, and you only need 2 points to draw a line, so I'm just going to kind of draw a line. Imagine that line is straight. Then, if we work the next 60 hours, we're going to make $15 an hour. So let me draw that with a different color. We can do this by drawing 2 points. So for the next part of this, the most that you can make, if you work 60 hours, this would be 15 times 60 minus 40 plus 400. So 60, this is 15 times 20 plus 400. 15 times 20 would be 300 plus 40. So the most that you could make would be $700. So at 60 hours, you're making $700. That would be this point. And so that line would look like that. Again, once again, just pretend that those are straight lines. And that's what your graph would look like. Sorry about those really bad lines, but I don't have a ruler with me. Okay? So your domain, the least you can work is 0 hours. The most you could work is 60 hours inclusive. Your range is the most money that you would make. So your range, the least amount of money you could make is 0. The most money you could make is $700. Okay? All right, we're going to go to the next one. And this is the last one. And I kind of want you to, why don't you pause this for a second, read it, and then sort of graph what it would look like. Okay, so welcome back. The first thing you need to know about this is that we're going to model distance. So distance is our rate times time. So if you're traveling 50 miles per hour for 3 hours, the distance, so distance is going to be our y value, and time is our x value. Okay? So distance is our output, time is our input. So if I travel 3 hours at 50 miles per hour, the distance that I would travel would be 50t. And I'm doing that for 3 hours, so I'm going between 0 and 3 hours. Then the next 2 hours, I'm stopped. So the next 2 hours would go from 3 to 5. I'm sorry, the next 2 hours would go from 3 to 5. And I haven't gone anywhere. So where was the last place? So I've already traveled 50 times 3 is 150 miles. So I've traveled 150 miles, 50 times 3. I've traveled 150 miles, so for 3 to 5 hours, I'm stuck at 150 miles. And then the last 4 hours, then I travel 4 more hours, so that's going to be at 5 to 4 hours, so 5 to 9. And this time I'm traveling 60 miles per hour. But remember, like we said before, we have to subtract the amount of time that we've traveled. So I have to, it's 60 miles per hour, that's my slope. But my time, I have to subtract the 5 hours that I've already traveled. And I have to add where I'm already 150 miles from home. Okay? So let's rewrite that. So this is our distance. And we're traveling 50 miles an hour for the first 3 hours. And then we stopped so we don't travel any further. Our distance remained 150. Again, I got that 150 because I've traveled 3 hours at 50 miles per hour. So for the next 2 hours, I'm steady. I'm not going anywhere. And then after that, for the next 4 hours, I'm traveling 60 miles an hour, but I have to subtract the amount of time I've already spent, which is 5 hours, and I have to add the distance I've traveled so far. Okay, so what would my graph look like? So from 0 to 3, I traveled 150 miles. So 150. My graph is a little, so I've traveled 150 from 0 to 3. Again, forgive me for my crooked line. Okay? Then for 2 hours, I'm not going anywhere. So from 3 to 5, I'm not going anywhere. So I just stay steady for the next 2 hours. And then I travel 60 miles per hour. Where do I end up in 9 hours? So I can just figure out my end point and draw my line. So I have to do some math here. So after 9 hours, I'm going to have 60 times 9 minus 5 plus 150. So that's 4. That's 60 times 4 plus 150. 6 times 4 is 24. So I would have traveled 390 miles. So at 9, 390, is that right? 390? Well, we're going to say that that's up here somewhere because we ran out of space. And would be up there somewhere. So that's what our graph would look like. Now I understand that this is a lot, and you have a couple of problems for homework, and we will do some more examples together in class. So just watch this again if you're confused. Try some problems for homework, and then we'll do some more in class tomorrow.